Today we are going to cover segments, line segments, and congruence. Remember, we talked about line segments last time, how they are a piece of a line. They're named by their endpoints. It consists of the two endpoints and all the points in the middle. But before we can get into that, there's a couple more vocabulary terms that we need. And the first one is a rule that is accepted without proof is called a postulate. And that is something, you'll see this one and the next one all the time in geometry. They exist in algebra and in calculus and all your other branches of mathematics, and even in other sciences. But geometry is really where you see a lot of them. So if we don't have to prove it, it's a postulate. That just means basically every time in all of history that someone has tried this out, it's worked. There's never been a way to make it so it doesn't work. A rule that must be proven is called a theorem. And you've heard of the Pythagorean Theorem. It has been proven to always be true. That's why it's a theorem and not the Pythagorean postulate. So those are just two terms that you will see over and over again. And the reason we needed to see those is because our very first thing we're looking at is called the Ruler Postulate. Remember, that means it doesn't have to be proven. And what it says is the points on a line can be matched up to real numbers so that we can measure the lengths of line segments. Basically, we can measure the lengths of line segments is what you need to understand there. Ruler postulate says we can measure length. The number associated with a point is called its coordinate. You did a lot of this in algebra where you had ordered pairs as your coordinates, but when you're just dealing with length, because there's no height, you only need one coordinate for it. And so if you look at this picture, we've got coordinates x1 and x2. Remember this little small 1 and this little small 2? Those are called subscripts. That just means the first x and the second x. They are different than exponents, which are when the numbers are up high. So when the numbers are down low, it's just telling us which x we're looking at. The names of those points are A and B. Now, if we want to find the distance between 2 points, we have to know its coordinates, and then we take the absolute value of the difference between the coordinates. So if we wanted to say the distance from A to B, okay, that would be the length AB. When we say that, we have A and B but with no bar over it. Length of AB equals AB without a bar over it. And that would be the absolute value. Remember, that's when we do those bars. Okay, and that tells us to make the answer positive. Okay, and it would just be x1 minus x2, whatever those numbers happen to be. You could do 2 minus 1 if you wanted to. x2 minus x1. It doesn't matter because we're gonna take the absolute value. And I'll show you that on example 1 here, how it does not matter which way you do it. Alright, so here we've got segment CD, and we want to measure the length to the nearest tenth of a centimeter. So our coordinate for C looks like it's 1. I'm going to change the color so we don't mix it up with the writing above it. It looks like C is 1, and it looks like D is 5.5. So if we wanted to find the length of CD, we would take the absolute value of 1 minus 5.5. Well, 1 minus 5.5 is negative 4.5, but because we're taking the absolute value, it's positive 4.5, and these are centimeters. The reason it has to be positive is because distance is always positive. If you walk from here to there, you are always walking in a positive direction. Even if you walk backwards, you are moving in a positive direction. When you get into physics, and maybe we'll do a little bit of it in here with vectors, vectors can be negative, but distance never is. If you don't know what a vector is, don't worry about it. You don't need it right now. We could also do this doing the coordinate of d minus the coordinate of c. So we could do 5.5 minus 1, which would give us the absolute value of 4.5, which is still 4.5. Either way you do it, you're getting the exact same result. All right, a concept that you need to be familiar with. You already are, you've just never explained it or had it explained to you. All right, if 3 points are collinear, so they're all on the same line, the point in the middle is between the other 2 points. This is only true if they're all on the same line. If they're not on the same line, you can't say one is between. So in this diagram, we could say B is between, and I'm going to use B/T to abbreviate that, A and C. D is not between A and C. So you can see, because D is not on the same line, it is not between the other two. All right, so ruler postulate basically said we can measure things. We can measure lengths. And then we were able to find the length between, the distance between 2 points. Now what we're going to move into is adding segments together. So this is called the segment addition postulate. And this is one of those things you are going to use all the time, so you need to know it. And it starts with if B is between A and C. So this only works when we have segments that are part of the same line. But basically what it tells us, and you knew this already, you just never gave a name to it, is the small piece plus the small piece equals the whole thing. Okay, so in this figure, the length of AB plus the length of BC equals the length of the whole thing, AC. And again, you've been doing this since elementary school. You just never gave it the name segment addition postulate. So for example 2, these cities lie in approximately a straight line. Find the distance from Lubbock, Texas, which is way down here in the bottom left, to St. Louis, Missouri, which is up here in the upper right. And Tulsa is not in the middle, but it is between them because they're all on the same line. So we know that LS, that's the whole thing, is going to be I'm going to color code this for you. Okay, is going to be LT. I shouldn't use green. Plus TS. So the length of LS equals the length of LT plus the length of TS. We don't know what LS is, so we'll leave it like that. We know LT is 380 miles, and we know TS is 360 miles. It might be hard for you to see on your paper. That's 380 and 360. So if we add those two together, we get 740 miles. So the distance from Lubbock, Texas to St. Louis, Missouri is 740 miles. And we got that by adding the two together. Again, you've been doing this before, but now we gave it a name. So take a moment, pause the video, and try these two problems, then I'll go over them. All right, XZ is this whole thing, and it's this piece xy plus, I can use green this time, this piece yz. So xz equals, xy is 23, yz is 50, so xz is 23 plus 50, so it will be 73. Now we don't have units on this one, so we just leave it as the number. For B, if wy is 30, can you use segment addition to get from w to z? So can we oh, went too far there. Basically, this is asking if we can figure out what wz is based on knowing that wy is 30. And the answer is no, we cannot, because y is not between w and z. Remember, segment addition only applies if you have two segments that are on the same line, if the point in the middle is between them. Example 3 is a little bit different because in this one we're given the whole thing, fh, and we're given one piece of it, fg, and we need to find the other piece. So when we don't know what it is, we'll call it x. And so this time we've got fh equals fg plus gh. It would be helpful for you to always write this statement out for right now. Down the road you can plug in as your first step without writing this down, but for right now I recommend you write it. So it'll be 36 equals 21 plus x. And this is why we reviewed algebra, because all of a sudden we've got an equation we need to solve. So to do this, we will subtract 21 from both sides. So 15 equals x. So we wouldn't write it like that. That is true, but we created the x. What we would do is write the length of GH equals 15. All right, now, a very important concept in geometry is congruence. Two line segments are congruent if they have the same length. So if the length is the same, then the line segments are congruent. If we have pictures and we want to mark that, we use little hash marks. So this tells us AB and CD are congruent. If we had multiple sets of congruent segments, then we would have multiple sets of marks, and all the ones that have the same number are congruent to each other. So right now they're congruent, but if I added a third mark, they aren't, because one has 2 and one has 3. So you need to look at the number of marks on them. Also, this tells us the length of, this right here says the length of AB equals the length of CD. So if we're talking about their length, talking about numbers, we would use equal. But when we're talking about segments, the actual figure, the picture, we use congruent. So we would say segment AB is congruent to segment CD. And the symbol for that, I'll draw it a little bit bigger, is an equal sign with a squiggle on top. So that says the pictures of these segments have the same length. Let's look at our last example. We're going to plot points J, which is -3, 4. Remember, you go left, right, then up, down to plot points. So -3, 4. That's point J. K is at point 2, 4. So we go right 2, up 4. L is at 1, 3, right 1, up 3, that's point L. And M is at 1, negative 2, so right 1, down 2. And I color-coded this because I knew what the question was going to ask. Determine whether JK, that's this segment, is congruent to LM, this segment. And this is where you can go back to, we did this on a coordinate plane so you can count your blocks. So JK is 1, 2, 3, 4, 5 units. So we know JK equals 5. LM is 1, 2, 3, 4, 5 units. So we know the length of LM equals 5. So we would say those are equal to each other, right? 5 equals 5. So we would say JK equals LM. This says the length of JK equals the length of LM. And then because their lengths are equal, we know segment JK is congruent to segment LM. So yes, they are congruent because their lengths are equal. So that's it for right now for segments and congruence. Make sure you fill out your Google form and get ready to do those practice problems in class together. Good luck.